Today we're going to finish out our integer operation thinking map. So we've talked about adding with the same sign, which is where you just keep the sign and add like normal. So a negative plus a negative, it's going to be a negative, and then you just add the two numbers. Same with positives. For adding with different signs, this one's a little bit trickier. You just have to keep the sign of the number that is bigger or has the bigger absolute value. So in -6 plus +4, -6 has a bigger absolute value, so our answer is going to be negative. And then we just find the difference between the two numbers. So the difference between 6 and 4 is 2. And then for subtracting, all we're doing is turning it into an addition problem. The way we do that is keep, change, change. So keep the first number the same, change the operation to addition, and then change the second number to its opposite. So if it was negative, you make it positive, and if it was positive, you make it negative. And then you just have to solve using these two rules, the adding rules. So let's talk about our very last operations. And the reason why, I know multiplying and dividing are two different things, but they have the same rule. So for both multiplying and dividing, if your two numbers have the same sign, so if two numbers have the same, oops, that's big, hold on. If they have the same sign, same signs, they're going to have a positive answer. And if they have different signs, they're going to have a negative answer. And then I want you to write that you multiply or divide like normal. Kind of like when we added with the same sign, we just add like normal. Here we're going to multiply or divide like we normally would, and then just figure out what the sign of our answer would be. So let's do some examples so you can see what I mean. So let's do two numbers that have the same sign like this. Let's do two positive numbers. So +3 times +2 is going to equal +6. See how my answer was positive? We had a positive answer. Okay, that one's pretty self-explanatory, right? Pretty self-explanatory, but what if I had two numbers with the same signs, but they're both negative? So if I had -3 times -2, that would be +6 again. I know it's weird, but -3 times -2 is going to be a +6. It's kind of like the opposite of this rule. It's kind of like the opposite of that rule. But whenever you're multiplying or dividing, the same signs give you a positive answer no matter what. So I'm going to clean that up. It's going to be a +6. So another way you might see multiplication is something that looks a little bit weirder like this. You might see like -3 times 2 with a little dot in the middle. It's not a decimal because it's bigger and it's not down at the bottom. It's in the middle of the two numbers, it's kind of floating. So this would be, since they have different signs, you're going to get a negative answer. So -6. Okay. Another way you might see multiplication, let's say you had 2 and then in parentheses you had -3. That's also multiplication. If you don't see an operation in the middle, like a plus sign or a minus sign or a division sign or anything like that, you're just going to assume it's multiplication. So 2 times -3 is also -6. Okay, let's do some with division. So let's do one with the same sign. Let's say we had -10 divided by -2. So we know if they have the same sign, that's going to give us a positive answer, so our answer has to be positive. Or you could think about it like, if you thought of division, like 10 divided by 2 means 2 times what equals 10. So you could think about this like -2 times what equals -10. What could I multiply -2 by to get -10? Well, the only thing I can multiply -2 by to get -10 is a +5. So that's my answer there. Okay. You might see division looking like this. Let's say I had -8 divided by -2. Remember, a fraction bar is just like a division problem. So since they have the same sign, it's going to give me a positive answer, so it's a +4. Okay, I'm going to draw little boxes around my answers. Forgot to do that earlier. Okay, let's do division with different signs. So if I had negative 12 divided by positive 3, that's going to get me a negative answer because they have different signs. Negative answer going to give me negative 4. Okay, or let's see if I had negative 15 divided by 5. Since that 5 is positive, but the 15 is negative, they have different signs, so it's going to give me negative 3. Okay, so just remember, same signs, positive answer, different signs, negative answer. I'm going to show you a way that you can kind of remember this. I like to call it the triangle method. So let's say I have a triangle that looks like this. So at the top, you're going to put a little plus sign, and then at the bottom, you're going to put little minus signs. Okay, reminds me of like a little mountain. So we've got the plus at the top and the 2 minus signs. So let's say I have a math problem and it is, so this only works for multiplication divisions. Let's do a multiplication or division problem. Let's do negative 3 times 6. Okay, so what I'm going to do is I'm going to look over here at my triangle. I'm going to cover up the two signs that I'm using. I have a negative here and a positive here. So I'm going to cover up a negative and a positive. Do you see how a negative is left over? Since a negative is left over, that tells me my answer is going to be negative. So my answer is negative 18. If I had negative 20 divided by negative 5, okay, let's cover up the 2 signs that I'm using. I have a negative and a negative, so I'm going to cover up my 2 negatives. The sign that's left over is a positive, so my answer is going to be positive. I'm going to draw a little positive sign so I don't forget. It's going to be positive 4. So my answer is just 4. Okay. Another thing you can do is a tic-tac-toe method. If you want me to teach you about that, just let me know and I'll show you. It's a little bit more complicated, so I like the triangle method just a little bit better. So the triangle method, you just cover up whatever 2 signs you're using, and then your answer is left over. If you write this triangle in your notes, I want you to write down below it, give it a little star, and say only for multiplication and division. I don't know how many times I see people try to use the triangle method for addition or subtraction. It doesn't work that way. It only works for multiplication or division. All right, so now your thinking map should be finished. I would like for you to come up with a so what. So remember, this is a summary. Tell me what's on your thinking map, and a so why. Why did we think, or why did we make this thinking map? Hopefully it should help you, so you can say something about how it's going to help you keep all the rules together, or it's a good reference for you to go back and see some examples. Whatever your reasoning is, please put it in your so why. Don't forget to use complete sentences for those. You can put your source. You could put Miss Posey as your source since I made this thinking map. You could write like 6th grade math, whatever you want to write for your source, wherever you got this information from.